Okay, this is my first video. Fortunately, I don't have a fancy camera, nor do I have an editing software, so this is all going to be one take, so bear with me. Welcome to your first video of U.I.L computer science. No, we're not going to be studying the science of computers. Rather, we're going to study programming and how to read and write code. And for those of you eager to learn how to read code, you're going to have to wait. Why? Because the first question in U.I.L computer science is about bases. Basically, we're going to be doing a lot of math. In today's world in math, we use base 10 in everything we do. You can notice this because we only use the digits 0 through 9 in base 10 because there are 10 digits, hence base 10. If you can't think of it this way, then why don't you just go to your number pad and you see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are the only digits you can see. You don't see a digit that's 10 because 10 is not a digit, right? Well, except in hexadecimal, but we'll cover that later. So basically, in base 10, well, I want to tell this basis first. So for question 1, in base 10, for example, we have the number 5,402. How do we express that in terms of the powers of 10? Well, we know that this is the ones place, this is the tens place, this is the hundreds place, and this is the thousands place, and so forth, right? But if you actually want to go into the details, this is actually 10 to the 0 power, which is 1, right? Anything to the 0 power is 1. This is 10 to the first power, 10 to the second power, and 10 to the third power. So we're going to multiply each of these numbers, and we're going to add them all together. So if we do 5 times 1,000, plus 4 times 100 plus 0 times 10 plus 2 times 1, we get 5,000 plus 400 plus 0 plus 2, which is 5,402. And that's how we express our numbers in base 10. And this actually works for any base. In computer science, or at least in U.I.L computer science, we get tested in binary, which is base 2, octal, which is base 8, decimal, which is base 10, and hexadecimal, which is base 16. Before we dig deeper into those bases, I first need to teach you how to convert any number from base 10 to base B. So for example, I wanted to convert 72 from base 10 to base, 4. How do we do that? Well, we actually need to list the powers of 4. So we're going to list 4 to the 0 power, then 4 to the first power, 4 to the second power, 4 to the third power, and so forth. Right? 4 to the 0 power is 1, 4 to the first power is 4, 4 to the second power is 16, and 4 cubed is 64. You could have also written 4 to the fourth power, which is 256, but 256 doesn't fit into 72, so there's actually no need to write 4 to the fourth power. So basically what we're trying to do is we're trying to see from the largest number, which is 64, or the largest power of 4, should I say, if that can fit into 72. And in this case, 64 does fit into 72. How many times does it fit into 72? Well, it actually fits into 72 one time. And then from there, we just do a little simple subtraction. 72 minus 64, which is 8. Now we see, okay, does 16 fit into 8? No, so we write down a 0. Now we go to the next power of 4, which is 4. Does 4 fit into 8? Yes. How many times? 2 times. And then 8 minus 8, right? Because 2 times 4 is 8, is 0. How many times does 1 fit into 0? 0 times. And that's your answer. So 72 base 10 equals to 1, 0, 20 base 4. There's actually an alternative way to do this, which is by dividing the number in base 10 by the base. So for example, 72 again. So if we have 72 base 10, what we'll do is we'll write the number here and we'll write down the remainders in this column. So now that what we do is we divide 72 by the power, which is 4. So if we do 72 divided by 4, we get 18, and it divides evenly into 72, so we get a remainder of 0. So we write down 18 here. Now we do 18 divided by 4, and we get 4 with a remainder of 2. Remainder of 2. Why? Well, I mean, 4 times 4 is 16, right? And 16 is 2 away from 18, so that's our remainder. And now we do 4 divided by 4 again, which is 1, with the remainder of 0. So I'm putting on 0 here, put that in 1. And we keep on going until this number right here is 0. So now if we do 1 divided by 0, 1 divided by 4, my bad, we get 0 with the remainder of 1. So now I'm going to write down 1 here and a 0 here, and now we're done. So now how do we get the number? Well, if you can't see from here, we actually go from the bottom up. So now 72 in base 10 equals to 1, 0, 2, 0, base 4. And again, this it doesn't matter which method you choose, they still give you the right answer. Personally, I like doing this method better, but I mean, now that I think of it, this method might be a little bit superior. I'm not too sure. I still need to work on it more. But these are just 2 examples on how to convert a number from base 10 to base B. In this case, I just chose base 4. Now, we need to know how to go from base B to base 10. I'm getting this. So how do we do that? Well, let's say I want to convert 63. Hold up, I'm just gonna. 63 from base 8 to base 10. So what we do is we write down the powers of 8. So we're going to write down 8 to the 0 power, 8 to the first power, 8 to the second power, and so forth, right? We get 1, because anything to 0 power is 1, 8, 64, and so forth, right? Now we see that 64 does not fit into 63, so we're going to write down a 0. And actually, in all these powers of 8, there's going to be a 0 in the front. So if you know your powers, you can easily not even have to write down 8 squared, which is 64, because it's not useful. So then we see, okay, well, 8 to the first power is going to be our biggest power of 8. So how many times 8 fit into 63? That's going to be 5, 7. Did I do that wrong? Alright, well, it's because I have all my notes in this piece of paper, and I did this part wrong. So basically, 7 actually fits into 8 fits into 63 7 times, because 7 times 8 is 56. So then we see, okay, well, 56. Oh my god, no, I'm dumb. Okay, you guys can scratch that. Scratch it. Don't even pay attention to this. I made a mistake. Wow. I I thought I was going to base 8. My bad. So basically what you're going to do is you're going to list the powers of 8. I'm not going to put down 8 to the 0 power anymore because that's just going to be a waste of time, especially during the test. So I'm going to write down a 1, and then I'm going to write down an 8, and I can see that 64 is not going to go into 63. So I'm just going to do like that. Then what I'm going to do is I'm going to write down the digits of 63 underneath 8 in the 1. And now what we're going to do is we're going to multiply these numbers and then we're going to add them to each other. Just like we did in this example. Right here. We multiplied them and then we added them. Same thing applies here. So 8 times 6 plus 1 times 3, which is 48, plus 3, which is 51. So 63 base 8 equals 51 base 10. And if you want to double check, you could list the powers of 8. 1, 8. You could go to 64, but you can see 64 doesn't fit into 51. So then you see, okay, how many times does 8 fit into 51? It's actually going to be 4 times. No, 6 times. 4 times. 4 times 8 is 32. My bad. 6. Oh my god. Sorry to guys. Today is not my day. It is the summer. Okay, so 6 times. Okay, 6 times 8 is 48. So now I'm going to do 51 minus 48. And we're going to get 3. So how many times is 1 fit into 3? 3 times. And we get our answer. It may be useful to draw lines just to separate all the numbers and everything. I guess because I'm more advanced, I waste more time, especially during a competition, drawing these lines. So I didn't even draw them at all. But what you guys could do is just do this. Right? Just to separate the numbers. It makes your work a lot easier and to follow. But I don't use it, but you guys definitely should, especially if you're a beginner, doing that. So again, yes, we figured out that 63 base 8 equals 51. How do you do it again? You list out the powers of the base b, in this case it's 8, and you put the number underneath, like exactly the way it looks like right here. And then you multiply the numbers, and then you add them. 8 times 6 is 48, 1 times 3 is 3, 48 plus 3 is 51, and that's how you convert from base b to base 10. I guess we can do it one step further, and we can say, okay, 763 base 8 equals what in base 10? What you do again, you list the powers of 8, 1, 8, 64, and then 256, no, 512, my bad. But 512, but as you can see, you only have 3 digits, so you don't need the 512. And what you do from there is you just multiply and add. So you multiply 64 and 7, and you add that to 8 times 6, and you add that to 1 times 3. So 64 times 7 is 448. 8 times 6 is 48, and 3 times 1 is 3. If when you add that all up, you get 499, which is your answer. Now, this way, I use this way during the test, but there's another way that I learned in actually, I believe it was number sense, and calculators, I think too. Well, back in junior high at least. We just had to convert a number from base b to base 10, but a really fast way. So let's say we had 763 again in base 8, and this works for any base. What we're going to do is we're going to multiply and add, multiply and add, multiply and add. Multiply what and add what, you may ask? We're going to multiply the base by the first digit, and then we're going to add the next digit, multiply by the base, add the next digit, multiply by the base, add the next digit, multiply by the base, add the next digit until you get to the very last digit. So in this case, how are we going to convert this to base 10? Well, it's going to be 8 times 7, which is 56. And we're going to add that to the next digit, which is 6. And that is 62. And now we're going to multiply that by 8, which is 496. And we're going to add that to 3. And we get 499 in base 10, just like our answer here. So again, two ways you can do this. One, you could just set the powers of 8, and exactly like it's shown here, you just put the number like that and multiply and add them. Or you could do this trick where you multiply the first number, add the next digit, multiply by the base, add the next digit, multiply by the base, add the next digit until you get to the very last number. Doesn't matter which way you do it, they both give you the same answer. Actually, now we need to talk about base 16 or hexadecimal, because it's actually very interesting. Let me just get a piece of paper. Might do this in a whiteboard next time. I just need to adjust this picture, this frame. It's been 16 minutes of me talking. Alright, so let's talk about base 16, which is hexadecimal. Well, we know that in any base, you can't go past that number. So if we're in binary, which is base 2, the only numbers you can have is 0 and 1. You can't have a 2 in base 2. Just like you can't have a 10 as a digit in base 10, right? So in hexadecimal, it's a base 16. So you may ask, well, that's going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But then you're going to have 10, 11, 12, 13, 14, and 15. But 10, 11, 12, 13, 14, 15 are 2 digits. So how can we express that as 1 digit? Well, what they do is they express 10, 11, 12, 13, 14, 15 as letters. I forgot what it's called. I think it's called alphanumeric, if I'm not mistaken. So basically what they do is they express in base 16, or like in base 11 too. It doesn't have to be necessarily base 16. Like in base 11, 10 would be A. And then so forth and so forth. But because we're talking about base 16, 10 is going to be the letter A. 11 is going to be the letter B. 12 is going to be the letter C. 13 is going to be the letter D. 14 is going to be the letter E. And 15 is going to be the letter F. A, B, C, D, E, F. And the rest of digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, are going to be the same digits. So let's say we want to express AF in base 16 to base 10. How do we do that? Well, what is A and what is F? Well, we said that A is 10 and F is 15. So the way I do it during the test is I'm going to express A as 10. I'm going to underline it so I know that this is 1 digit. If you don't underline it, then you need to make sure that you know that this is 1 digit. Because this, to me, if you don't underline it, you may think of it as just a 10. And then F is 15. Right? And then we're going to convert to base 10, so we're going to list the powers of 16, 1, and 16. And then we're going to multiply them and add them. Right? 16 times 10 is 160. 1 times 15 is 15. When we add them, we get 175. So that's your answer, 175. Or you could do the trick, which is 16 times A, or 16 times 10, and then you add 15. Same thing, it doesn't really matter. Just remember, it's very important. I really suggest that you guys underline, just to make sure that you guys don't get confused with 10, 11, 12, 13, 14, 15, and as a digit, as a single digit. Remember, these are single digits in base 16. And yeah, I mean, well, actually, let's go backwards first before get into some little tricks on binary. So let's say we want to work backwards from 175 to 16. So let's write 175 base 10 and what's that in base 16? Well, we list the powers of 16, which is 1, 16, and I believe the next power is 256, but 256 does not fit into 175, so there's no need to write it. Now, from here, we need to see how many times 16 going to 175. And if we just simply multiply by 10, we see that we're going to get 160, which fits into 175. If we multiply by 11, we're going to get 176, which is 1 over 175. So we're going to write down a 10 here. So then we get 175 minus 160, and we get 15. How many times are we going to 15? 15 times. And then how do we express this as a letter? Well, we said that 10 was A and 15 was F. So this is going to be AF. Okay. Now that we've gone over hexadecimal, I'm going to show you guys some quick tips on binary, and this is actually very useful. I should have used these tricks a long time ago. This is why question number 1 can be a little bit tedious if you don't know these tricks. Now these tricks are very fast. They're not really tricks. It's just something cool about binary. Just wait here. Okay, so let's say you want to convert from binary to octal or from binary to hexadecimal. Well, first you need to know how 8 and 16 fit into the powers of 2. So we know that 2 to the first power, to the second power, to the third power, to the fourth power. This is 16, this is 8, this is 4, this is 2, this is 1. Right? So because in this case, in the example I'm showing, I'm going to convert to base 8. 8 is 2 cubed. We're going to notice this 3 right here. So let's say I had, for example, 1, 1, 0, 1, 0, 1 in base 2. And we want to convert it to base 8. Normally on the test, what I would have done is I would have converted to base 10 and then convert that to base 8. But there's a really fast trick to go from 2 to 8. And that is, first we're going to list the number in binary. 1, 1, 0. We're going to draw a line. 1, 0, 1. What you guys should have done is actually should have done it backwards. 1, 0, 1, draw a line. 0, 1, 1, draw a line. But because I noticed that these are 6 numbers, I evenly split it in half. And then what you do here is you just write down 1, 2, 4. 1, 2, 4. Why? Well, it's almost as if we're converting to base 8. 4 plus 2 is 6, plus 1 is 7. That's the highest number you can make in base 8. You can't make an 8 in base 8. So we just, because these are our ones, we can just add these numbers up, except the one with the 0, because anything times 0 is 0. So 4 plus 1 is 5, so I'm going to write down a 5. And 4 plus 2 is 6, so I'm going to write down a 6. And that's your answer, 65. Let's try another example. Let's say perhaps we had, I don't know, 1, 1, 0, 1, 0, 1 base 2. Actually, that's the same number, my bad. No, this one. 1, 0, 0, 1. Yeah, that's better. Okay, I'm gonna convert that to base 8. How do we do it? Again, we're going backwards. We get 1, 0, 1. We draw a line. 0, 1, 1. Draw a line. And 0, 1. And then we write down 1, 2, 4. 1, 2, 4. 1, 2. We can write down a 4. and put a 0 if you want, but it's really unnecessary. And now we just add the numbers. So we get a 2 here, 6, and a 5. So our answer is going to be 265 in base 8. And you can check this if you want, if you go to base 10, but just believe me. Okay, now what if you want to convert from base 8 to base 2? Simple. Let's say we had 265 in base 8, for example. It's just a lot easier. If you want to convert 265 in base 8 to base 2, how do we do that? Well, what you can do is you can see that there's 3 digits. So we're going to have to do 3, 1, 2, 4, 1, 2, 4, 1, 2, 4, right? We're going to do that 3 times. So I'm going to do 1, 2, 4, 1, 2, 4, 1, 2, 4. Right? What combinations of 4, 2, and 1 can give me 5? Well, I know 4 plus 1 is 5. So I'm going to write down a 1 and a 1. What combinations of 4, 2, and 1 can give me 6? I know 4 plus 2 can give me 6. So I'm going to write down a 1 and a 1 here. And what combination of 4, 2, and 1 can give me 2? It's just a 1. Right? And then the rest of the numbers you can fill with zeros. 0, 0, and a 0 here. You can write down a 0 here, but it's really useless. You can just treat it like that. And that's your answer. It's 1, 0, 1, 1, 0, 1, 0, 1. Which is the exact same number we got in here. So really, this is a very simple trick that's going to be very, very useful in question number 1. But let's do the same thing with base 16. So for example, if you had, let me draw a little 1, 0, 1, 0, 1, 1, 1, 0, 1, 0, 1. Base 2 is what? Base 16. 16. 2 to the what power gives you 16? 4. So we're going to have to do 4 digits. So we're going to split it up in 4s. It's basically what I'm trying to say. If you split it up in 4, we're actually going to have 1, 2, 4, 8. And then another 1, 2, 4, 8. And then if you put down the numbers, 1, 0, 1, 0, 1, 1, 1, 1, 1 plus 1 plus 1, not 1, 8 plus 4 plus 2 plus 1 is 15. Another neat trick that might be useful later on in computer science when we go over like bytes and everything, if all these are filled with 1s, then it could be expressed as 2 to the 4th power minus 1. Not necessarily 4, but the reason it's 4 is because we have 4 digits here. 2 to the 4th power 16 minus 1 is 15. That only works if all the numbers are filled with 1s. If they aren't, well, then you just kind of add them. And in this case, we have 8 and 2. 8 plus 2 is 10. We're right on 10. Remember, these are digits. So what's 10 in base 16? That's an A. And what's 15 in base 16? That's an F. So this is actually a F. If you wanted to do, I don't know, B, A, D in base 16 equals what in base 10? Base 2, my bad. What we have to do is we're actually gonna, okay, so we have 3 digits. So we're going to do 3, 1, 2, 4, 8. So 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. Okay, so B we said was 11, right? Because A is 10, B is 11. So actually what I'm going to do it in 11 right here. A is 10 and D is 13. This makes it a lot easier for our work. So what combination of these numbers can give me 11? I know 8 plus 3. So 1, 1, 1. What combinations can give me 10? 8 and 2. And what combination can be 13? 8 and 4 is 12, plus 1 is 13. So my answer is going to be 1, 0, 1, 1, 1, 0, 1, 0, 1, 1, 0, 1 in base 2. What's next? Oh, now we get into the actual, okay, so this is all just fundamentals for question number 1. Question number 1 actually deals with the addition and subtraction of bases. They can be similar bases or not so similar bases. But with this trick I just showed you, you can make adding not similar bases much faster than converting from base B to base 10 to base B. Again, let me just get another piece of paper. Okay, so we do base 10. Let me just align this. We do base 10, right? So, for example, 17 and 18. If you want to add them, 7 plus 8 is 15. We get to 1, and we get 3. So 17 plus 18 is actually 35. But actually, let's dig deeper, like, why? Well, first of all, we noticed that we didn't even write a 10. That's because we use base 10. And there's no need to write a 10 there. Just like when you do logs, the common log is in base 10. So you don't do log 10 of whatever number it is. You just do log whatever number it is. Because 10 is the base that we all use. Now, why we put the 5 down and carry the 1? Well, it's because 7 plus 8 is 15. And 15 has one group of 10 with 5 remaining. So we put down the remainder, which is 5, and we put down how many groups of 10 we have, which is 1. And then we added them. We got 3. That's how we do similar base addition. So for example, if we had 1, 0, 1, 1, 0, 1, 0, 1, and 1, 0, 1, 1, 1, 0, 0, and these are both in base 2, and we add them, how do we do it? Well, 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 1 is 2, but we're in base 2. How many groups of 2 do we have? We have one group of 2, and we have 0 left over. 1 plus 1 is 2, put on 0, carry the 1. 1 plus 1 plus 1 is 3. We have one group of 2 with 1 remaining. So we have put on a 1 and we carry a 1. It's going to be 0, carry the 1, 0, carry the 1, 0, carry the 1, and we now write the 1 down. And we get 1, 0, 0, 0, 1, 0, 0, 0, 1 in base 2. And that's our answer. What if we did this in base 8? Well, same thing. Let's say we have 32, base 8, 56, base 8. 2 plus 6 is 8. So we're going to write down a 0 and carry the 1. Why? We had one group of 8 with 0 remaining. Now we have 5 plus 3, which is 8, plus 1, which is 9. We have one group of 8 with 1 remaining. So we're going to put in a 1, we're going to carry a 1. 1 plus 0 is just 1. Put on 1 down, and that's your answer. 110 in base 8. Another example, 67, 56, 56, base 8. 7 plus 6 is 13. Right? How many groups of 8 do we have? We have 1 with 5 remaining, right? Because 13 minus 5 is 8. Carry 1. 6 plus 5 is 11. Plus 1 is 12. How many groups of 8 do we have? We have 1 group of 8 with 4 remaining, because 12 minus 8 is 4. Carry the 1. And 1 plus 0 is 1. So that's our answer in base 8. We can even do that for 16. Base 16. Let's see, we had 23 base 16 and 52 base 16. We wanted to add them. 2 plus 3 is 5, and 2 plus 5 is 7. That's it. That's your answer. That was actually pretty simple. But if we do another more challenging one, let's say we had BAD plus AF. How do we do that? Well, just simply rewrite it as, let me just make sure it's in the shot. Here it is. 11, because that's B. A is 10, and D is 13. A is 10, F is 15. And now we add them. 13 plus 15 is 28, right? 16 goes in 28 one time, with the remainder of 12. This is 21. 16 goes to 21 one time, with the remainder of 5. And 1 plus 11 is 12. That's it. But remember, these are digits. So we actually express that as C5C, because C is 12 in base 16. And we're done. It's very important that you can add in the same base. Try not to convert to base 10, or convert, like, try not to convert, let's say, let's pick on this for a while. Don't convert 32 base 8 to base 10, 56 to base 8 to base 10, and then add them up, and you get your answer in base 10, and then convert it back to base 8. That's just, it'll take a lot of time. You'll most likely get the right answer, but it'll just take a lot of time. If you just straight up add and use your knowledge of multiplying regularly like you do in base 10, then you should really get the right answer. But you just, it's a time test, 40 minutes, the computer science test, and you don't want to wait a lot of time in question number 1. So if you can add the same bases, that's actually going to be very, very useful. And now we're actually done with basically question number 1. Now I'm going to actually show you guys how question number 1 looks like in the actual computer science test. Actually looks like this. Let me get the camera real quick. Most of the questions is which of these is not equivalent to 88 base 16 minus 206 base 8. They're mainly like 2 different bases, and you want to add them or subtract them, or they can be in the same base. It doesn't really matter. So for example, question number 1. Question number 1 is actually a really easy question. Question number 1. Well, question number 1 in this bases PDF that I actually made a while back. This is all about bases, but most of it is actually dealing with actual like code, as you can see here, or 2's complement, which I will go over in my next video. I think maybe. So in this question number 1, it says here, which of these is not equivalent to 88 base 16 minus 206 base 8? Now let's look at the answer choices. We have 2 base 16, 2 base 8, 2 base 2, 2 base 10, all the way equivalent. The answer is actually C, 2 base 2. Why? You can't have the same number with the same base. There's no 10 base 10. Well, I mean, there is, but 10 is not a digit in base 10. It's actually made of 2 digits. So you can't ever have this. Just like you can have a 8 base 8 or a 7 base 7, right? If this was a 1 and a 0, then they all would have been equivalent. But in this case, it isn't. But let's actually work on the next problem together, and maybe we can use a little bit of the tricks that we learned earlier to get this question faster, right? Normally, what I would have done in the test is I would have converted this to base 2 and then add them up and see if D is the answer. And if it is the answer, as in if it's right, then it's not the answer, because which of these is not equivalent? Make sure you read the question. But the way I would have done that is not using a trick. I actually would have converted to base 10 and then converted to base 2, which actually is going to take a while longer. But if you know the trick, it'll be much faster. So I'm just going to write that down real quick in this piece of paper. Oh man, I wish I had a piece of paper. Okay. Actually, I'm going to get another piece of paper. Just wait. I'm sorry if this was being edited. This would have been way better experience for you guys. Get a piece of paper. Not equivalent to 10111000. IB 16 101 11000. Then we have 163 base 16 355 base 10 543 base 8 1011 0001 base 2 all are equal. Okay, let me just put this back. Oops. Is it in the shot? Okay. So remember, the question says which of these are not equal. So basically, if any of these choices is equal to that, you can just scratch it out. So how do we tackle this problem? Well, you can either convert this to base 16 and add them, or convert this to base 2 and add them, or convert it. You can do it any single way. Actually, what I'm going to do is I'm going to convert this in base 2 to base 16. So the way I would do it is we're going to get 1 0 0 0 and 1 1 0 1, and this is 1 2 4 8 1 2 4 8. So this is going to be an 8, and this is going to be 2 plus 8 is 10 plus 1 is 11. 11 in base 16 is B, so this is going to be B8. But because we're adding, I'm just going to stick to 11. A is 10, B is also 11. So this is actually going to be AB base 16 plus B8 base 16, which equals to 10, 11, 11, and 8. 11 plus 8 is 17. 16 goes into 17 one time with the remainder of 1, right? 10 plus 11 is 21, plus 1 is 22. 16 goes into 22 one time with the remainder of 6. And 1 plus 0 is just 1, base 16. So if we look, you get 161 base 16, 163 base 16. And if I look at the answer choice for question number 2 in my PDF, the answer is for 2 is D. Hold on. A is 10, B is 11. So B. 17. That's weird. It says here that the answer is D, but I got A. Did I do something wrong? Oh, it's 9. Yeah, no. Okay. Well, I already spoiled it for you guys. I made a mistake. 11 plus 8 is 19. Why did I think that it was 17? 11 plus 8 is 19. So it's goes into 16 goes into 19 one time with the remainder of 3. My bad. So this is out because it is equivalent, right? Now we can convert this into base 2, which is what I would do next. So to convert that to base 2, what you do is you list down, we have 3 digits, so it's going to be 3, 1, 2, 4, 8s because we're in base 16. So it's going to be 1, 2, 4, 8, 1, 2, 4, 8, 1, 2, 4, 8. So we're going to have a 1 here and a 1 here because 2 plus 1 is 3. To get 6, we have a 4 and a 2. And to get 1, we have a 1. So 0, 0, 0, 0. So now we checked this answer with this answer. 1, 0, 1, 1, 0, 0, 0, 0, 0, 0, 1, 1. This is missing a 1. So my answer is this. If you want, you can even check base 8. How would you check base 8? Well, we know that the answer is actually 1, 0, 1, 1, 0, 0, 0, 1, 1. If we split it into 3s, we get 1, 2, 4, 1, 2, 4, 1, 2, 4. We get 5, 4, and 3. 543 base 8. That's out. Now if you want to check base 10, what you do is you list down the powers of 8. 1, 8, 64. And then 5, 4, 3. 64 times 5, 20, 2, 32. 8 plus 4 is 32. And 1 times 3 is 3. We get 5, 5, 3. So that's out. And because actually we got that this was out, this was also out too. And the answer is D in this case. Sorry about my mistake, guys. Yeah, so knowing these tricks, you get the answer very easy. Don't convert to base 10 and then to base B. It's not efficient at all. But if you know all these fundamentals that I just showed you, then you should be able to get the first question in less than a minute if you actually practice. Now, those of you that are watching this in the Google Classroom, I might post this on YouTube, I'm not too sure, but I'm definitely going to post this in the Google Classroom right after I'm done hitting the stop button in this video. Look at the basis problem, the packet, the PDF that I put in Google Classroom, and just keep on practicing. This is question 2 in the packet from the Google Classroom. If we just continue working on the other questions, you should be able to do this very quickly. Don't waste your time doing number 1 if you've already been taking 3 minutes to do it. In the past previous U.I.L meets, honestly, I didn't know these tricks until research, and I'm actually going to use this during the U.I.L meets so I can increase my time because it's pacing, a lot of pacing. 40 minutes to complete 40 questions, or at least as much as you can. Now this is a very easy papier test question. If you don't know how to read code or whatever, you could definitely do this. This is just basic math. The next question in the computer science is actually question 2, like an actual test, and it is basic math 2. However, that math actually deals with data types, and I'm going to go over that in the next video. But for now, this is bases. Please watch this video. It's going to be very important. because I'm probably gonna teach this when school starts again. And if you miss out on practice or whatever, you can just easily go click the video on Google Classroom and just watch me lecture here rather than at school. That way, I don't have to go every single time. Oh, Michael, can you teach me about bases? Michael, can you teach me about bases? Where you can just watch the video, and that actually saves time for me and saves time for you. You don't have to go bothering me, and I don't have to be getting out of my way teaching you just because you didn't pay attention or because you didn't show up during my lecture, I would say. Thank you for watching. Stay tuned for the next video. Yeah, bye.